Okay, so the first video was kind of a nice warm-up. Now we're ready to tackle something with a little more meat on it. And these are going to be where the denominator has irreducible quadratics. So our first challenge here, we see the degree of the numerator is less than or equal to, or is less than the degree of the denominator, so we don't have to do any long division. But now we're challenged with trying to factor that denominator. So, hoping that you remember, we tried doing this before, factoring by grouping. If we pull out the x squared, that will leave us with an x minus 1, and there's not really anything we can do with that. So we can pull out the x minus 1, leaving behind the x squared plus 1. So this becomes x squared plus 4x plus 1 over, and in factored form we have x minus 1 and x squared plus 1. Now x squared plus 1 we cannot factor any further, so that's what we mean by an irreducible quadratic. So we are going to decompose this into some constant we're going to solve for over the linear part, but now the quadratic part needs a bx plus c, so an x term and a constant, possibly. So we are going to factor it like so. Now we're going to, as we did before, clear those denominators, so we will multiply by the least common denominator, which needs both the x minus 1 and the x squared plus 1. So on the left side, everything cancels. We're going to get x squared plus 4x plus 1. On the right side, the a is going to survive. The x minus 1 will cancel, and we'll have to multiply that by x squared plus 1. And then we're going to get the x squared plus 1 to cancel. We're going to have a bx plus c, and then our x minus 1, our x minus 1 will survive as well. So now we don't have, it's not quite as slick as it was before with the linears, but we can try to plug in some values here. I think x equals 1 is going to be a nice one because of this x minus 1 term over here. So if we do that, then on the left side we get 1 squared plus 4 times 1 plus 1. That's going to give us 6. Plugging in 1 for x, 1 squared is 1 plus 1 is 2. We're going to get 2a, and then nicely enough the right side, or the next term just becomes 0 because of the x minus 1. And so we get a relatively pain-free to be 3. Now, there isn't really a terrific way to go, but we can maybe choose x equals 0 is always reasonably nice. So if we plug in 0 and use the fact that we know a, we're going to get 1 on the left side of the equal sign. We're going to get 0 squared plus 1 is 1, times a, which is 3, is going to make that be 3. Choosing 0 is going to make the b disappear, and so we're going to get a plus c times 0 minus 1, which is negative 1. Well, that wasn't too bad. So I'm going to add the c to the left, subtract the 1 to the right side, and we're going to get c is equal to 2. Now, you can choose whatever seems like a nice number. Negative 1 or 2, either one of those seems reasonable because they're not very big. And we're not going to get perfection, but it's okay because we got a and c. We only have one more variable we have to find. So if we plug in 2, 2 squared is 4, 4 times 2 is 8, 4 plus 8 is 12, plus 1 is 13. The a we know is 3, and we're plugging in 2, so 2 squared plus 1 is going to be 5. And we're trying to find the b, so I don't know that, but we're going to get 2 times b is going to be 2b plus the c, which was 2, and then the 2 minus 1 was 1, so that part at least was kind of nice. So let's see, we got 13 equals 15 plus, that's going to be 2b plus 2. So I guess if the 15 plus 2 is 17, subtract the 17 from the 13, is a -4, and so we're going to get our b is -2. So our partial fraction decomposition is going to be the a, which is 3 over x minus 1, plus the b, which is -2x, plus c, which is 2 over the x squared plus 1. All right, that wasn't too bad. I think that's about to change. So now we're going to do repeated irreducible quadratic factors. Repeated irreducible quadratic factors. Quadratic factors. So it's a good news, bad news thing. The good news is nothing with quadratics here is going to be on the AP exam. The bad news is it will be on my exam. So let's look at 2x to the third minus x squared plus 5x all over, and we're going to call that x squared plus 1 quantity squared. So we look at the degree, and the degree of the numerator is 3, and we can see the degree of the denominator is 4. That's good news, at least. We don't have to do any long division. Now, because we have the repeated quadratic factor, we're going to get a bx, or I guess I can go a. So we can say, because I don't have any linear factors to worry about, so I haven't used a yet. So I'm going to go ax plus b over the x squared plus 1 to the first, and then continuing along the alphabet, cx plus d over, and we're going to need an x squared plus 1 squared. Okay, hopefully that makes sense. We can multiply through by our least common denominator. And so on the left side, everything cancels in the denominator. We're going to get 2x cubed minus x squared plus 5x. Hoo boy. On this side, we're going to get one of those x squared plus 1s to cancel, but we're going to get another one that comes through. Ooh, that's not going to be pretty. And then we're going to get a cx plus d. Okay, now here's going to be our strategy. We're going to multiply out everything there, that ax plus b times x squared plus 1, and then we're going to gather together like terms, and then we're going to equate coefficients. That may not make sense. Let's see. First, let's distribute. So ax times x squared is ax cubed. And then we're going to get a plus bx squared. And then we're going to get a plus ax. And we'll get a plus b, and we still have the cx, and we still have the d. Now, if we look at the only x cubed term is the ax cubed, and the only x squared term is the bx squared. But we have two terms with x in them, so if we factor out that x, that's going to leave behind a plus c, and then we have two constants, so we're going to lump them together as b plus d, and if you want to put them in parentheses, you can do that to make it make sense, to keep it more organized. It's up to you. Now, the key, though, is we're going to equate coefficients. So the only way that this left side can equal this right side for all values of x is if the coefficient of x cubed here is equal to the coefficient of x cubed there. And the coefficient of x squared here is going to equal the coefficient of x squared there. And the coefficient of x here is going to equal the coefficient of x there. And I'm running out of colors, but we're going to get that the constant here is going to have to equal the constant here, which would, of course, be 0. Okay, so that's the strategy. Let's see how it works. So the coefficients of x cubed, that's nice because we get 2 is equal to a, and we got it figured out. The coefficients of x squared means -1 is equal to b. Well, that was pretty nice. We know what b is. The coefficient of x, 5, must equal the a plus c, but we already know what the a is. So that's going to be 2 plus c, so c must be 3, and we got that pretty pain-free. And then finally, we're going to get the constant 0 on the left must equal b plus d on the right, but we already know what b is, that's -1, and so that means that d must be +1. Oh, that was kind of nice. So then, at the end of the day, our partial fraction decomposition is going to look like ax plus b, which is 2x minus 1 over x squared plus 1. And then the cx plus d is going to be 3x plus 1 over the x squared plus 1 quantity squared. All right, guys, that's about as hard as it gets. So we can hopefully do homework number 19.